All right, here we go. Video number 3 for Ms. Decker. Let's see how it goes. So here was our warm-up. It said to solve each equation for y. In other words, we're going to rearrange the equation into slope-intercept form. So we're looking for y equals something, mx plus b. So this first equation, we've got this negative 5x we want to get rid of. So we're going to use our inverse operation. The opposite of subtracting 5x is adding 5x. So we're going to add 5x to both sides. Those cancel. We end up with just y on the left side. And on this side, we have negative 3 plus 5x, or we could put it in slope-intercept, 5x minus 3. Either way is the same thing. This equation, we have a 4x here. We want to get y by itself, so we need to get rid of that 4x. Right now it's being secretly added, so we're going to subtract 4x from both sides. 4x minus 4x is 0, so we are left with just y on that side. 8 minus 4x on the right side. So, and we have solved for y. All right, this one, it's looking a little more difficult, but same thing. We're going to add or subtract the 6x so that we can get this y by itself. The opposite of adding 6x is subtracting, so we'll subtract 6x from both sides. That'll leave us with just negative 3y on the left. And on the right, it doesn't matter what order we write it in, we'll end up with negative 12 minus 6x. Before we were writing it in slope-intercept with 6x before the constant, before the number, but at this point in time it doesn't matter. But we don't have y by itself yet, do we? We need to divide by that negative 3. Each term, that's going to leave us with just y on the left. Negative 12 divided by negative 3 is 4. Negative 6x divided by negative 3 is a positive 2x. Last one. Again, we're solving for y again. So we're going to do the opposite of subtracting 7x, which is adding 7x to both sides. On the left, negative 7x plus positive 7x gives 0, so we're left with just 2y on the left. And on the right, we have 13 plus 7x. But we're stuck with that 2 still, so we're going to divide each term by 2. 2 divided by 2 is 1, so we're left with just y on the left. 13 divided by 2, can't do anything, we have 13 halves. We could do an improper fraction, but let's not waste our time. And 7x divided by 2 just gives us 7 halves x. Alright, that was our warm-up. This is a skill that will come in very handy for what we are doing, what we are learning about today, which is solving by substitution. So on the other side of your warm-up, I gave you this little weird situation, and I said, oh, how weird. I totally forgot to edit it. I didn't know what I was going to use for the student name. So would you please plug in, instead of wherever it says student name, just cross that off and say it's Billy. And then you went along and you said, okay, that's Billy. And he said, it doesn't really matter, but that's Billy too. And so now you had the story. Billy says that the system of equations below has no solutions. Here's the system. Is Billy correct? Show or explain how you know. Can you do it without graphing? What you just did was you substituted Billy in for student name. I told you that the student name is equal to Billy. And then when you did the work, you could say, Billy. You didn't have to say student name anymore, right? You know that the student name is the same as Billy, because I told you that. So Billy is right because the lines are parallel, and you can tell that because they have the same slope but different intersects. Different y-intercepts, I should say. So if you were to graph that, you would end up with 2 lines that were going in the same direction, whatever direction that is, and they would never touch. But really, my secret, what I really wanted to talk about, was this right here. That's really what I cared about today. All right, so let's move forward. What we are going to do is we're going to solve a system of equations by substitution. Basically by doing what you just did here in a math sense, where I told you that wherever it said student name, plug in Billy, and you were able to use that and come up with an answer that made sense, instead of saying student name is right. All right, let's take a look and see what I mean. This is just a preview. You don't need to write any of this down. Let's say I had this equation, 3y plus 2x equals 16. And let's say I then told you, hey, guess what? Y equals 6. Well, what would you do? You just plug in that 6 wherever it says y, right? And then you would be able to solve. You'd say, all right, so 3, not 3y, but 3 times 6, because that's what I told you y equals, plus 2x equals 16. And now you would say, okay, 3 times 6 is 18, plus 2x equals 16. Continue solving, subtract 18 from both sides. You end up with 2x equals negative 2. Divide both sides by 2. And you say, oh great, Ms. Decker, because you told us that y equals 6, I'm able to tell you that x equals negative 1. You substituted this in and solved for x. Simple enough? Let's move forward then. What if instead of giving you a number, I said, hey boys and girls, y is equal to x plus 2. Well, you might not think that this is going to help, but it's actually going to help a lot. Because what I'm going to do is I'm going to take that blob for y, I'm going to plug it in for y. And I'll have 3, and instead of y, x plus 2, plus 2x equals 16. Now I can solve. I've got to distribute, so 3 times x is 3x. 3 times 2 is 6. Copy down the rest of the equation, plus 2x equals 16. Combine my like terms. 5x plus 6 equals 16. Subtract 6 from both sides, and you have 5x equals 10. And then divide both sides by 5, and you have x equals 2. Isn't that cool? Because I told you that y is the same as x plus 2, you were able to substitute that in and tell me what x is. Now the only question left is, but what is y? We still don't know what y is. So what we would do then is we would substitute that x equals 2 into that original equation, and we would say y equals 4. We're going to do that more a little bit later. So now we have an x, we have a y, we have a solution to the system. And we didn't have to graph it all. Okay, so let's move on. All right, so here are your notes. And so what we have is we have our two equations. That is our system of equations, just like you had before when you solved by graphing. And the first thing we need to do is solve either one of these equations, for one of its variables. So I'm going to turn this into either x equals something or y equals something. Well, I happen to know by looking at this, I think the easiest thing to solve for is this x. So let me take that equation. X minus y equals 1. Add y to both sides. I'll end up with x equals 1 plus y. All right, so that's my equation there. I've rewritten it so that I have a single variable on one side. Doesn't matter whether it's x or y. I chose x just because it's easier. Okay, so now I have my x equals 1 plus y. And I'm going to take my other equation, which just came from the top. It's one part of my system, 3x plus 2y equals 8. And step 2, I'm going to substitute the expression that I found in the substitute the expression found into the equation that I didn't use. And now I'm going to solve for y. So I'm pretending I know what x is, and now I'm going to figure out what y is. So I'm going to take that expression and substitute it in for x. So let me rewrite that. I have 3 instead of x. I'm going to write 1 plus y in parentheses. And now I'm going to copy down the rest of my equation. Plus 2y equals 8. And now I'm going to solve. 3 times 1 is 3. 3 times y is plus 3y. Copy down the rest. Plus 2y equals 8. Combine my like terms. 3 plus 5y equals 8. Isolate my variable y, so I'll subtract 3 from both sides. 5y equals 5, divide both sides by 5, and I'll get y equals 1. Great, I know what y is. Now I need to go back and figure out what is x. So the last part, I found out that y equals 1. And I'm going to substitute that into, ignore this, I'm going to use one of my original equations. That's going to save you time. I'm going to use one of the original equations. So, doesn't matter which one. I'll take my easy one. X minus y equals 1. Substitute 1 in for y. X minus 1 equals 1. Add 1 to both sides. And I'll have x equals 2. Now I know what x is and I know what y is. And so I think I have a solution to my system. This is the same as the point of intersection when we graph them in a line, but we didn't have to graph them now. But how do I know for sure that this is really my point? Because we all make mistakes. I'm going to check my answer. And this is exactly what you used to do for graphing. I'm going to plug it in to both equations. X minus y equals 1. Plug in 2 for x and 1 for y, and I find out 2 minus 1 does indeed equal 1, so it works for the first equation. My second equation was 3x plus 2y equals 8. Plug in my x and my y, so I get 3 times 2 plus 2 times 1. Does that equal 8? Sure enough, 6 plus 2 does equal 8. It works for both equations, so that is indeed my solution to the system. And no graphing needed. Isn't that exciting? Let's do it again. Okay, so here we have again, this is our system. There's our two equations. I'm going to solve one of them for its variables. I picked the first equation. It looks a little easier. It really doesn't make a difference. And I'm going to solve it for x. That means I'm going to move my y's over here. So I'm going to add 3y to both sides. I'll have 3x equals 33 plus y. Need to keep isolating for x. So I'm going to divide each term by 3. And I end up with x equals 11 plus y. X equals 11 plus y. So now I'm going to take the other equation, which was 4x minus 2y equals 16, and I'm going to plug my expression for x in for x. And when I rewrite that, I'll have 4 times, instead of x, this expression, 11 plus y. Again, I'm going to put that in parentheses. Copy down the rest of my equation. Minus 2y equals 16. Distribute to solve. 4 times 11 is 44. 4 times y is plus 4y. Copy down the rest of the equation. Minus 2y equals 16. Combine my like terms. 44 plus 2y equals 16. Isolate for y. Subtract 44 from both sides. I'll end up with 2y equals negative 28. Divide both sides by 2. Y equals negative 14. So now I have my y. I need to get my x. So I've got my y, negative 14. I'm going to take one of my original equations. I'm going to substitute negative 14 in. So I'll have 3x minus 3 times, instead of y, negative 14, equals 33. Start solving. 3x plus 42. Remember, a negative times a negative is a positive. 3x plus 42 equals 33. Subtract 42 from both sides. 3x equals negative 9. Divide both sides by 3 to isolate x. X equals negative 3. I have an x. I have a y. I have what I think is my solution. Negative 3 comma negative 14. How do I know for sure? I need to check my answer. So I'm going to plug my x and my y into my original equations. And if I end up with a true math statement, I have a solution. So there's my original equation. 3x minus 3y equals 33. Plug in my x, plug in my y. I think that equals 33, or at least it should. Solve. Negative 9 plus 42 does indeed equal 33, so it works with my first equation. Check with my second equation. 4x minus 2y equals 16. Plug in negative 3 for x, negative 14 for y. I think that should equal 16. Do the math. Negative 12 plus 28 does indeed equal 16. That is my solution. So this is negative 3, negative 14 is my solution to the system. Yay. All right, next one. Try it on your own first. There's our system. Pause the video. Try it on your own. Did you pause and try it on your own? All right. Well, here's the icky part. You may have solved for a different variable. But I looked at this and I said, oh my goodness, look at that that x all by itself. I'm going to solve for x because that's going to be so simple. So I took that equation and all I had to do was add 5y to both sides. And I ended up with x is equal to 220 plus 5y. All right, so now I've got that. X equals 20 plus 5y. I'm going to take the other equation, 8x minus 10y equals 10, and I'm going to wait right here while you plug that in and try it out. Did you try it? All right, so I'm just plugging that in for x, substituting that into my equation. 8 times 20 plus 5y minus 10y equals 10. Distribute out. 8 times 20 is 160. 8 times 5y is 40y. Copy the rest of my equation. Combine my like terms. 160 plus 30y equals 10. And solve for y. Subtract 160 from both sides. Gives me 30y equals negative 150. Divide both sides by 30. I get y equals negative 5. So I have my y. I have an actual number for y. Okay. What am I going to do next? That's right. I'm going to substitute that negative 5 in for one of my original equations. Go ahead, pause, and try it. All right. So I substituted that in. I had x minus 5 times negative 5 equals 20. X plus 25 equals 20. Isolate x. So I subtract 25 from both sides. I end up with x equals negative 5. I have my x, I have my y, I have what I think is a solution. How will I know for sure? That's right, I'm going to check my solutions. Or check my solution, one solution. All right, let me know if you have questions. Come on in during lunch or after school. I am more than happy to help, but you need to come and ask and reach out for that help. Thank you for watching.